Welcome back, everyone, and today we're going to do one more video about shields, related all to depth buffering and everything else. So we have a shield. We created a nice, really cool animated shield. We had two versions of it in the last previous video. So the last thing I wanted to do is create an impact effect. I just wanted it for completion sake. If you guys are going to use the shield, at least have some kind of way to do an impact. And how you do an impact effect on a shield, you might not even realize how to go about it. So a common effect for impact is kind of just a wave. As you can see in like an anime, you have a wave. When it's impact, you kind of create waves in the shield. And the same thing here in related to games. You hit the impact and there's like a wave in that shield. So that's what we're going to do. We're going to work toward making that impact, kind of just a wave, that ripple effect that kind of just goes around the shield. So that's what we're working toward today. So, couple of changes to fungi. We're going to have a new file called shield simple. So this way we're going to use our simple shield, because in the previous lesson I had the simple shield and the fancy shield all mixed in together in the same file. So now they're separate. We're going to have a new one called shield hit, which is going to be our impact. Shield got changed, so this way it only has that one version of it, the complicated version. UV sphere has some changes done to it, and I think there might be one glitch, one bug I fixed. Can't remember. It's one of these lines. The big change in our UV sphere is data has been split from it. So we have like geometry, UV sphere geometry, and then UV sphere, where UV sphere actually gives you the whole renderable all set up. So this, because I kind of want to be able to just have the geometry be generated and use it for things without having a renderable built for it. So you got that new change. Again, here's the changes. You can go look and follow along if you're following along development. Like I promise you guys, I will point out the changes, but I'm not going to step through line by line unless it's very important anymore. Renderable, I just added a new function to renderable so we can clone. I thought that'd be a great, quick way to do it. So this way you kind of reuse the same VAO. You just want a whole new copy of this renderable, but sharing the same VAO. So this way you're not duplicating data on the GPU. GL, small upgrade to empty float array buffer. So this way I can create an empty float array buffer set up for instancing. So that's all that this one does. That's what the small change for that. So that's that for code changes, really. And so I leave this pretty much the same thing. We're going to use noise 01, and we got our two shield simple, shield hit. Everything's pretty much the same as the last lesson. So the new global variable called shield hit, and we're going to make a copy of the shield. We're going to move the exact same position as the shield, which if it's clone, I don't think I copy the position when I clone it. So I probably should, but and then I scale it. Now, if you notice that the scale is slightly different. So you might actually be, why am I creating a copy of the shield? Well, the reason why I'm creating a copy of the shield is because if I want to create an effect, especially multiple hits, it's easier just to create another mesh to handle that effect. So I can have my one sphere mesh or renderable actually animating, creating that shield, but then I can have a secondary sphere that's kind of overlaps it that can do another effect right on top of it. So you start, like I said, you're kind of layering effects on top of each other. And the reason why the scale is off by a little bit, because if they are scaled exactly the same, you're going to have Z buffering like issues, which you kind of I want to avoid. Like because if the effect is on the exact same Z direction distance, the pixel might not blend correctly. So just having it slightly bigger than the actual effect will actually make the effect perfect. So it's just making it just slightly. It's kind of like a glove. You know, if you put a glove on, it's not the exact same size as your hand, but it's very close. You know, you don't want it to be tight. You want it to be slightly loose fitting, not too tight. So that's the idea behind it. You're gonna put a glove on top of your other object. So it's like paper wrap or something. It kind of just goes on top of it. Does not actually match. Does not occupy the exact same space. It just kind of goes on top of it a little bit. So that's why it's a little bit bigger. And then we're just changing its material. And since we're doing all this stuff, and it's a post effect on top of that, we do the update matrix right here. And we end up just adding it to our post render. So we're going to render our shield. We're going to render our shield hit right on top of it, right after another. It's also not writing to the depth buffer. So it's, like I said, you're layering a bunch of post effects. So maybe I should show you what it looks like at the very, very beginning. So in the very, very beginning, here's our simple shield, right? And we want that ripple effect. And I already have a shader set up with the base requirements of it. So the ripple effect is right here. Let me see. How does it look like if I actually have it occupying the exact same space? I'm just curious. You know, maybe you guys might be curious. It might work just fine, but you're better off always making sure you're a little off. It works, but I think I had problems. I think when it starts animating and you start doing alpha blending, things get funky. So you're better off that way. So there is our little ripple, right? Now, how is this ripple being done? Well, the ripple is being done because we're kind of creating basically a dynamic texture. Now, a sphere, if you remember when we built it a long time ago, it's polar coordinates. So you think about like the texture square kind of wrapping around the sphere. So you'll have kind of like a seam over here. So like let's say over here is you know, actually down here is 0, 0, and up here is 1, 1, and we kind of just wrap it around the texture. But since it's a kind of a spherical way, the texture that we're actually going to be dynamically creating looks like this. And since we're wrapping this square onto that sphere, it looks like a circle. So even though we're basically dynamically just creating a straight line, just like a colored straight line and hopefully in a transparent texture, when you wrap it around, it just makes it into a nice complete circle. So that is basically the mechanics of how to build that ripple. So we use a sphere, we create a dynamic texture, and we're not even really building a texture. We're just taking the UV coordinates and coloring them. It ideally is kind of like a virtual texture, essentially. So if we go into shield hit, go to the top, let's see what we got here. We got our usual stuff. We're going to have an instance, because this way we can have the idea is that we're going to do multiple. We can allow multiple hits, so you can do 3 or 4 hits on the shield, and we're going to use the instancing to create multiple copies of the shield, and rotate it based on where the impact was. So this way, the impact happens exactly where it's supposed to be. Let's rotate. So this is, and then we have our Quintorian rotate function that we can kind of add here. You know, we give it a rotation value, and we give it a thing. So we end up rotating our vertex first based on our instance. Then we take our overall re-renderable model matrix, and then we kind of add everything else to it. Everything stays the same, and then we have our fragment shader. We're still doing map testing. We still have to do that. And then we kind of have a bunch of constants where these can actually become uniforms. We want to make this more controllable at a material level. So we're going to say the lifetime of the ripple is about 2 seconds. So it takes about 2 seconds from the shield to go from from the South Pole all the way up to the North Pole. It takes 2 seconds. That's how long a ripple takes to travel. This is the ring size, how big the ring is going to be, which is essentially kind of like how long is this line? It's about 5 or 8 pixels tall. That's basically what we're saying the ring is, just how tall it is. And we're going to add a little fade to it, and we're going to give it we're going to let the ring grow over time. So we're going to do our depth testing, make sure everything is correct, because like I said, we're doing all this stuff manually now just for these post effects. And this is all we need to kind of just create that ring. So we're going to have time, basically, and I'm using time as the starting point of our texture. So if I say the starting time is 0.01, we might be like starting here, somewhere like right here. So we're drawing right there. And then I'm saying R, which I'm going to say is ring, so it's T plus this. So that's how I want to add another 0.1 to the ring. So basically, I'm just adding a little bit more. So that basically, let's say 1 is about that. So now it's twice as thick. So it's kind of like the starting position and then the actual thickness. So if I wanted to actually change the position, let's see what it looks like now. So I'm going to make it a little smaller, like closer, like more in the beginning of life. So if I start this, get closer to the South Pole. So I'll take that plus 1. It'll still just be the same thickness, but it'll be smaller. So, and if you want, you can make the ring a lot smaller as well. So you can kind of control the ring size. Let's see. Let's make it thinner. Refresh. There you go. So and like we're always doing, we're just getting T and we're getting R, and we're just testing Y. The Y on the. Because remember, this is basically X over here. This is the X position, and this is the Y position. So we're just testing Y, and anywhere that's within that range of Y, we're going to color in and make that little line. So that's all this is doing. So if it's between the start of T and the end of R, if it's between those two values, we're going to color it black, or no, actually we're going to color it white with full alpha. Else we're going to color it white with 0 opacity, 0 alpha. So this is completely transparent. Now, the thing is, we want to be able to see this correctly. So, since everything, since the way the textures work on a sphere, for this specifically is based on polar coordinates, we want to be able to, like this right here is like the forward direction of our sphere. So we kind of need to create an offset. So the South Pole is our forward. So we're just going to add rotation to our shield. It's going to do -90, so we're going to rotate on the x-axis by 90 degrees. So if I refresh, there you go. So now we just rotated it. Now the South Poles now the poles are here in the forward direction. It's forward and that's back. So when we create instances, for every rotation we have to add the offset. So if we say the laser beam is coming from this direction, we need to take this direction plus that 90-degree offset, so this way the shield will actually point directly where the laser beam is coming from. Because we are going to do a little bit of laser beamy things to show where the impact is happening. So now if we go back to shader, now we can just animate it. So we can animate distance. So since T is really just the starting position of our texture, we have time that passes in, and we said our time is 2 seconds long. So we're gonna get the modulus of time, and then divide by time, which normalizes time. So we get a value between 0 and 1. And by doing that, we create that ripple effect. Now the ripple effect goes right across. And since we're doing depth testing, that's why it looks pretty good. If we don't do depth testing at all, it doesn't look right at all. It doesn't work. Yeah, so that's why we kind of need to do depth testing. So manually, because it's just not working. So if we do that ourselves, we know to go around the cube. So there you go. And that's a simple thing. So now let's get rid of this simple example, and we're just going to take it a little bit further. So we still have T and R. So it's the same thing as I did up here. It's just time. And now the ring size is going to be 0.5, but that's the maximum size of the ring. It's going to be 1.5. So it's going to be 1.5 times T. So T goes between 0 and 1. So this way, so during time, we're going to change the starting position of our ring, and we're going to change the size of our ring. So it's going to grow over time. You know what? Before we start doing all this stuff, why not we do that to our simple? So this way you kind of get to see it look like before we start applying all those colors and whatnot. So let's see what it looks like. Did I screw up? Ring size times T. Ring size. Oh, that's our ring size is 0.8. That's how big the ring is. Yeah. It's just not working. Oh, did I screw up? Oh, freaky. All right, I guess I screwed up. I don't know what I did wrong here. Huh. Oh, whatever. I guess we just have to do it with the effects. I don't see why that's acting up. We're just changing the R value. All right. All right. Let's see. All right. So we're going to just start animating it and do some other fun things to it. So we're going to just do this part. So let's see, what is this? This draws a solid ring. And this, I don't think I'm even using R anymore. Am I even using R anymore? That's probably part of the problem. Well, it shouldn't change this part. But, so the way I'm doing it now is that we're still going to do by the starting position. Yeah, but I am using R. And I'm adding T to R in here. And that's maybe why it doesn't work. Okay. Okay. That's why. The way the value has changed. It's times T. I also have to add to T. Okay. Screw it. Let's just see how it works this way. So now I know what the mistake was. Up here I needed to add T as well. For up here, it has to be that plus T for it to work with this if statement. But since we have all this commented out, let's go look. So we're calculating this ring size based on time, and we're calculating the starting position is time. So if it's greater than time, equal to, or less than time plus the size of the ring, because the ring is going to change. I think the reason why I did this is because I'm using R somewhere else, so I needed the R value to be by itself. So if it is that, we're going to change the alpha based on ring grow. I don't remember. So let's see what this looks like. Okay, so that's what we're doing. So based on ring grow, yes, time, ring grow, I'm mostly going to change the alpha value. So as time progresses, it actually starts fading away. And as you can see, the out colors are already RGB. So we're just setting the base color, which is green, which I probably haven't mentioned yet. So now we got this other white ring, we got the green, and it fades, and the ring grows a little bit. See, but that doesn't look so good, you know? because it's the solidness. It's very solid. So the next thing you can do, so I'm adding as an if thing, you can actually fade the beginning. So if I take t minus fade ring, so I want before t, I want to kind of fade into t. So the idea is, let's see if I can, how can I, when we, so let's see, I guess the idea, you probably get it, I probably don't need to really illustrate it, but maybe I should just in case. So let's say t is here, right? This is my t. This is going to be my solid color. I want to start fading maybe like a few pixels away. So I'm going to say the starting fade is here. So between here and here, I want to fade. So this is kind of our fade effect. But then t until the ring size, I don't want it. I fill in. So less than t, some value less than t till t creates that fade effect. Then t till ring size creates the solid color. So it goes from faded to solid. So it's kind of like a double. We're going to do two things. And hopefully I illustrated it correctly for you to understand. So like I said, so that's what we're taking t. We're taking away the fade. It's the fade of solid. Yeah, it's a static constant. You can animate it too. You can make the fade smaller. So we're just smooth stepping between those two values, and then multiplying it by time. So I guess I am changing it, the value. What? Well, let's see what it looks like. I'm just curious what it, because I think I'm probably just reversing it. So there you go. So with the little fade effect, it looks a lot better than the solid color. So it looks more like there's an actual impact right here in the center. What does it look like without this? I don't remember why I added that to it. I did this like a couple days ago. I totally forgot. Oh, okay. It creates that weird double effect. Oh, because I'm probably going over 1. That's why. That's why I'm going over 1 for some reason. And I don't know why this fixes it, to be honest. I totally forgot how. When I'm making this stuff, I'm kind of just little by little, and I didn't write comments why I'm doing this part. But it helps fix that little double effect, and that's because I'm going over the value of 1. So I'm taking that t row value, so inverting it, and then make sure I'm clamping it between these two values. So this way I got rid of that effect, and it looks a lot better that way. And there you go. Now you have that ripple effect. And that's really most of the effect. All right. So, sorry I can't really explain why this one I'm doing that one for. But I know it has, we saw it because that has that little double effect at the end, because I think as I'm going over the value of 1. This takes the, let's see, smooth step starts at t minus, so it's the smallest value to v y. Based on the growth. Oh, I'm setting the alpha value. Oh, okay, now I get what's going on. All right, I'm sorry. I didn't even realize I'm changing the alpha value. This calculates this fade area. That's what I'm doing. I'm sorry. So that's the fade area I'm calculating. So that calculates the fade area. This part, based on growth, calculates how much to fade. So that's why I'm multiplying between 0 and 1. So the further away I am, it should be 0, and the closest to it should be 1. So I get that full, almost alpha value applied to it. So that's what's going on. Okay, I'm sorry. This creates the size of the fade, for the start and end, and this changes the alpha value for it. All right, there you go. Now I feel better explaining the math to you. I really should comment that. Oh my god. Okay, so that's it. So now we're going to do just some last minute things. Now we're going to have to deal with instancing. All right, so that's our thing. So I created a class object that's going to basically handle our shield ricochet. So if I click save, everything's the same, and I say apply hits at 90 degrees. So it knows to be at 90 degrees. So if I want to say like 120 degrees, refresh. So I know it changes. Now what this thing is doing right now is actually creating an instance. So it's actually creating one shield on top at that degrees and rendering it. So if you scroll to the bottom, we have our shield hit. This is our renderable. Has all our basic settings, and it has an instance size. And it creates, like I said, here's why I changed the UV sphere, because I just want the geometry, because I want to create a whole new VAO. If you're going to build a real game engine, you should really create maybe a buffer, a way to kind of just create buffers by themselves, and make them as a resource item, because all this stuff is being duplicated for this shield and the actual shield. Ideally, you would want, even though you want different VAOs using the same data, right now I'm duplicating it because in the framework, Fungi framework can't really cache buffers. But if you're gonna do a very optimized game engine, you really should make buffers into resources themselves. So this way you can kind of say this is spheres, vertices, spheres normal, spheres UV, spheres index, and then you like if in this instance if I want to make a shield, I can reuse those buffer values in this VAO and just add my new buffer, which is B rotation. But like I said, right now I'm actually creating a copy of all the data, putting it on the GPU as a second copy of it. So like I say, it's not the most optimized way because it's the same data duplicated twice on the GPU. But like I said, we're just prototyping. We're just trying to get things working. But what I'm doing here is not the best optimized way of doing it. So just keep that in mind that Fungi itself is not super optimized. So I just wanted to point that out so you guys know if you're doing this, think in the back of your head that this stuff, a lot of these buffer data should be cached in a way that we can reuse them multiple times. Most often we don't need to. Most often we create a buffer and that's it. But like certain things, any primitive should be shareable. Just in like spheres, cubes, things, those should be very shareable. So this way you can create multiple VEOs based on the data in case you need to do like special things to it. But the overall data stays the same, like the vertices, normals, UVs, and the index. All right. So, and the only it's pretty much a regular VAO that we usually have, except I'm adding an empty float, which will handle. Well, we pass in quatorians, and we're giving it B size. So B size is 4 floats per quatorian. We're going to do 3. So we're only going to do about 3 rings maximum. So I'm only going to have enough binary data or binary space to store up about 3 quatorians for instancing. If you want to increase how many you can do, you can just increase the value to like 10 or 20 or 200. How many impacts you want to be able to render at one in a given time. And if you want to do kind of and on top of that, you might need a second empty buffer, which would basically maybe be starting time, and change the shader. So this way, all the impacts are going to be synced up together, so they're all going to happen at the exact same time. If you're going to do like a game, you probably want a second thing that goes with rotation is start time. So this way, the animation for the rings can start at different points in time. So this way, you can have one ricochet happen, and then halfway done with the ripple, whatever you want to call it, another one starts. You'll see how it is. This is kind of like the starting point. This is not the end final version of what this shield hit should look like. But I'm just telling you, like I said, there's things you should know if you're really going to use this. So that's it. And this is like the basic idea of a hit. So we pass in like an angle. We convert it into radians. And we say we want a new quaternion, and we're going to rotate it. We want a rotation of x on that radius. And then we just push that data into an array that we then push to the GPU. And then we use divide by 4 to know how many quaternions in here. And this function only allows one copy of it. So if I get rid of this, and up here in our render class, or render function, uncomment this. So I'm going to keep track of time, and every time 2 seconds go by, I'm going to reapply new hits. So when the hits are done, I'm not keeping track of when hits are happening, but I'm going to create new hits, and I can add up to 3. So we're going to try with just 1 for now. And see, this is the simple one, and this is the one that actually does all the good work. So it's the same, like I said, it's the same idea as this one. Now the only difference is we're going to do multiples. So we can pass in multiple arguments, and we're going to, I probably should do it up to, whatever. So whatever argument is, we're going to pass in basically, what are we passing? We're passing in angles, or? Yeah, we're passing in vector. So we're going to pass in a vector direction. That's what we're going to do. So we're going to randomly pick a spot in 3D space, and we're going to basically shoot a laser beam from this spot. So from that spot in space, some random spot. So we're going to have like maybe a random spot like here. So from the center to here, we're going to pass in this position, and then we're going to calculate the things related to it. So we're going to make a copy, or we're going to just, instead of using arguments, we're just going to make a shortcut for an alias or pointer to it, whatever you call it, to that vector. So we're going to clone that vector. We're going to subtract the position of this object. So basically, we're this together. It's basically beam position minus shield position. So that's what's happening here, because I'm making a copy of it, because I don't want to modify it. So I'm make a copy of it, and then subtract position, so it's beam starting position, shield position, and then I normalize it. By doing that, I create a direction vector. So I know the direction vector from the shield to the beam. That saves as the D direction, and then I clone that. Then I add the position of the shield itself, because we need to offset. So if the shield is moving, we need to move it, because this is all normalized, essentially. So I need to move it to the exact position. And O is only needed to draw the line, because this part is not really needed at all. This is just showing you the point of impact, really. Yeah, it's gonna be where I stop drawing the line, and V is where the line starts, and this is where it stops. It's kind of it's the math for a point of impact, I guess. That's why I have it written down as. So we're gonna take a quaternion. We're gonna take our direction vector, and we're gonna do a look rotation to it, and we're gonna do that offset. Remember, it's we want the south pole to be our front view. So even though we have our look rotation, we have to then kind of just add an extra rotation to it. This is our offset. So we're just taking whatever that rotation is, adding an extra 90 degrees on the x-axis to it. So this way it's actually pointing exactly to it. And then we just pass in that quaternion information into an array, and we kind of draw the line, and then we just do it. So this way we can do up to 3. So now if I click refresh, there you go. There's our laser beam. Another laser beam. Another laser beam. And you can see every time like the laser beam is created, it looks like a ricochet is happening at that spot. So red is the point of impact, and black is where the actual the random direction that we're the random point in space we're creating. Now, if I want, go back into our render, we can just add another one, another random spot. Click refresh. I gotta add the comma. See, I knew where the problem is. There you go. We got to wait 2 seconds, and now we got two points of impact. Now the only thing I really can't do is it'd be kind of nice if when two ripples happen, they could kind of merge, or kind of like if they hit, they kind of cancel each other out. It'd be kind of cool to do that, but I don't know how to go about doing that. I think that makes things a hell of a lot more complicated. Like you have to know per pixel where everything is. So, but this is good enough for, you're not really going to realize it. And then right now, it's actually rendering two spheres on top of this sphere. So like I said, for every ring of impact, it's a new sphere that's being rendered on top. And then, like I said, we set everything up to have a maximum of 3. 2 seconds later, and now we got 3 ripples. 3 random impacts. And there you go. This is the end of the video. And this is how we apply an impact effect on top of our shield. So this way, if you kind of have guns or magic attacks, you can hit it, and it looks like you actually hit the shield. So like I said, very simple. It's just the idea that you have to draw spheres on top of your regular sphere, and you can use instancing to basically and to really just create as many hits as you want. So this way, they have that little class file. Just give it all the points of rotation, and there you go. If you're going to do this, you're going to use this for like a real game or for a real. You would have to fix up the object to maybe during every second or something to keep track of. First of all, like I said, you need to set a time. So this way, because right now everything is synced up, you want them to not to be synced up at the exact same time. You want the ripples to happen when they really start. So you need to add an instance value of start, and then change the shader to use that time as a starting point for to do the animations. And let's see. And the other thing you would have to do is that you kind of have to check to see all the ripples. You basically have to keep track of all the ripples you're having, and then once the time expired, you take that time out of your instance value. So if let's say you have 2 rings and they start like half a second apart, when the first one is done, you should take that off the list, because if you leave it on the instance list or on the instance buffer, the animation might just loop over again. So you kind of just want to animate it and take it off the list. So and on top of this, since you're not rendering multiples, and when that buffer is empty, when you have nothing to render, it shouldn't render at all. So you don't want to do a random instance when we don't need to. So you should only. So that's like the other thing you should do when you're actually going to use this for a game. You have to really keep track of when the impacts happen, when they finish, and then take them off the instance list, instance buffer. So this way you not rendering the extra shield, the extra sphere, and animating it when you don't need it. So that's the end for our shield. I'm not going to do shield effects anymore for now. Just going to leave it as is. I'm going to do a different video about something today. I'm actually going to record it because I spent all night doing it. But it's kind of like a coding challenge, and I'll post that today along with this. And after this, I'm going to do some 2 videos about voxels. I already created a simple voxel system that we can use. It's great. It's starting to work. I'm almost done putting it together. So it's going to be 2 parts. I'm going to deal with the data, and then dealing with actually making it 3D. So yeah, that's it. So I guess I'll see you guys at the next lesson. Please like and subscribe. I got a new Patreon. I keep forgetting to go look at the names. Thank you very much. Thank you, Christmas time. Thank you for donating to the series. So yeah, I think that's it. I got another video to record right after this, so I'll just end this short. So yes, like and subscribe. Happy New Year's, Christmas, yeah, all that stuff. So I'll see you guys at the next video. Bye.